Welcome to our comprehensive module on configuration management in DevOps. I'll be your instructor for this crucial component of modern software development and operations. Configuration management is a fundamental pillar of DevOps practices, and its importance cannot be overstated in today's rapidly evolving technology landscape. Throughout this module, we'll explore how configuration management serves as the backbone for maintaining consistency, reliability, and scalability in our systems. Whether you're new to DevOps or looking to enhance your existing knowledge, this module will equip you with both theoretical understanding and practical skills in configuration management. We'll cover everything from basic concepts to advanced implementation strategies, using popular tools like Ansible, Chef, and Puppet. Let's begin this journey together and discover how configuration management can transform your approach to system administration and software deployment. Let's begin by understanding what configuration management really means in the context of DevOps. At its core, configuration management is about maintaining control over your systems and applications throughout their entire lifecycle. Think of configuration management as the conductor of an orchestra. Just as a conductor ensures each musician plays their part correctly and in harmony with others, configuration management ensures each component of your system is properly configured and works in concert with other components. In practical terms, this means automating and standardizing how we set up servers, deploy applications, and manage system changes. Instead of manually configuring each server or application instance, we define our desired state once and let our configuration management tools ensure everything stays aligned with that definition. The role of configuration management in modern DevOps practices is transformative. It bridges the gap between development and operations by providing a common language and framework for defining infrastructure. This becomes especially critical as organizations scale their operations and need to maintain consistency across multiple environments. The significance of configuration management in modern IT operations cannot be overstated. Let's dive deep into why it's become such a critical component of successful DevOps practices. First, let's talk about consistency and standardization. In today's complex IT environments, having consistent configurations across all systems isn't just convenient, it's essential for reliability and security. Configuration management ensures that whether you're spinning up your 100th server or your first, they'll be identical in all the ways that matter. Regarding scalability and growth, configuration management is what makes rapid expansion possible without sacrificing quality or control. When your business needs to quickly deploy new resources, whether it's during a holiday shopping season or a product launch, automated configuration ensures you can scale up without introducing errors or inconsistencies. The collaboration aspect is particularly fascinating. Configuration management serves as a single source of truth for your infrastructure. Instead of knowledge being siloed in different team members' heads or scattered across various documentation, everything is codified in your configuration management tools. This means new team members can quickly understand how systems are set up, and changes can be reviewed and tested before being implemented. System reliability and availability improvements through configuration management come from two main factors: reduced human error and consistent state management. When configurations are automated, you eliminate the typos and oversight that often occur with manual configuration. Additionally, configuration management tools can automatically detect and correct drift from the desired state, ensuring your systems remain reliable over time. While configuration management offers numerous benefits, it's important to understand its challenges and potential drawbacks. Being aware of these helps us prepare for and mitigate them effectively. The initial learning curve and setup can be steep. Teams need to learn not just the tools themselves, but also new ways of thinking about infrastructure. It's similar to learning a new programming language. There's an investment of time and effort required before you see the benefits. Some teams struggle initially, especially when transitioning from traditional manual processes to automated configuration management. Dependencies on tooling and infrastructure can create new points of failure. Your configuration management tools become critical infrastructure components themselves. I've witnessed situations where issues with the configuration management system prevented teams from deploying urgent updates. This underscores the importance of having robust backup and failover procedures for your configuration management infrastructure. The challenge of handling legacy systems is particularly noteworthy. Many organizations have existing systems that weren't designed with modern configuration management in mind. Adapting these systems can be complex and sometimes requires creative solutions or compromises. Let's explore some practical use cases where configuration management truly shines in real-world scenarios. Server provisioning and configuration is perhaps the most common use case. Instead of manually setting up each server, configuration management allows you to define server configurations as code. Application deployment and updates become much more reliable with configuration management. You can define your application's requirements, dependencies, and configuration in code, ensuring consistent deployments across all environments. This is particularly valuable in microservices architectures where you might be managing dozens or hundreds of application instances. The integration with CI/CD pipelines is where configuration management really shows its power. By automating both infrastructure and application deployment, you can create truly automated delivery pipelines. Some organizations achieve multiple deployments per day with confidence, something that would be extremely risky with manual processes. Disaster recovery and backup management benefit greatly from configuration management. When your entire infrastructure is defined as code, recovering from disasters becomes much more straightforward. Instead of relying on documentation and manual processes, you can automatically rebuild your environment exactly as it was before the incident. Let's explore the major configuration management tools that dominate the industry today. Each has its own strengths and unique approaches to solving configuration management challenges. Chef, as an open-source tool, uses a unique approach with its concept of recipes and cookbooks. These are essentially Ruby-based configuration scripts that define how your infrastructure should be configured. Chef's approach is particularly powerful for complex, code-first environments where you need fine-grained control over your infrastructure. Puppet, another popular open-source tool, takes a slightly different approach with its declarative language and manifests. Instead of writing step-by-step instructions, you declare what you want your system to look like, and Puppet figures out how to make it happen. This approach can be particularly effective for maintaining large-scale infrastructure where consistency is crucial. Ansible has gained significant popularity due to its agentless architecture and use of YAML for playbooks. Its relatively gentle learning curve and human-readable configuration files make it an excellent choice for teams new to configuration management. Some teams become productive with Ansible in days rather than weeks or months required for some other tools. Each of these tools has proven itself in production environments. The choice between them often depends on your specific needs, existing infrastructure, and team expertise. Let's compare these major configuration management tools to help you understand which might be the best fit for your needs. The agent-based versus agentless architecture is a fundamental difference between these tools. Chef and Puppet use agents that must be installed on managed nodes, while Ansible operates over SSH without requiring additional software on target systems. This architectural difference has implications for security, scalability, and ease of implementation. Regarding learning curve and ease of use, Ansible often has an advantage due to its straightforward YAML syntax and push-based model. Chef and Puppet, while more powerful in some ways, typically require more time to master. I've observed teams new to configuration management become productive with Ansible much more quickly than with other tools. The community and ecosystem surrounding each tool is vibrant and active. All three have extensive libraries of pre-built configurations you can leverage. For instance, Ansible Galaxy, Puppet Forge, and Chef Supermarket provide thousands of community-contributed modules and configurations. Integration capabilities with other DevOps tools are crucial. All these tools can integrate with common CI/CD platforms, cloud providers, and monitoring solutions. However, the specific integration approaches and ease of implementation can vary significantly between tools. Now let's focus on Ansible, one of the most popular configuration management tools in the DevOps ecosystem. Ansible has gained significant traction due to its simplicity and effectiveness. Its agentless architecture and use of SSH for communication make it particularly attractive for teams looking to implement configuration management without adding complexity to their infrastructure. What makes Ansible special is its approach to automation. Instead of requiring agents on managed nodes or complex master-slave architectures, Ansible works over standard SSH connections. This means you can start automating your infrastructure with minimal setup and overhead. The tool's use of YAML for playbooks makes it highly readable and accessible, even for those new to configuration management. This readability also makes it easier to maintain and modify configurations over time, which is crucial for long-term sustainability of your automation efforts. Throughout the rest of this module, we'll dive deeper into Ansible's capabilities and learn how to use it effectively for various configuration management tasks. Let's walk through the process of installing Ansible on a bare metal system. This is often the preferred installation method for development environments and smaller deployments. The installation process is straightforward, but there are some important considerations to keep in mind. First, Ansible is Python-based, so you'll need Python installed on your control node. The control node is the machine from which you'll run Ansible to manage other systems. When running the apt-get commands shown on the slide, it's important to understand what's happening behind the scenes. The update command refreshes your package index, ensuring you're getting the latest version of Ansible. The install command then pulls down and installs Ansible and its dependencies. After installation, verifying the version is crucial. This helps ensure the installation was successful and confirms which version you're running. Different Ansible versions may have different features or syntax requirements, so knowing your version is important when following documentation or troubleshooting issues. Consider using Python virtual environments for Ansible installation, especially if you're working on multiple projects that might require different Ansible versions. This can help prevent version conflicts and keep your development environment clean. Now let's explore how to install and run Ansible using Docker, which offers several advantages for testing in isolated environments. Docker provides a clean, consistent environment for running Ansible, which can be particularly valuable when working in teams, or when you need to ensure everyone is using the same Ansible version and dependencies. The installation process is straightforward, but understanding each step is crucial. The first step assumes you have Docker already installed on your system. If you don't, you'll need to install Docker first. This varies by operating system, but Docker's documentation provides clear instructions for all major platforms. When pulling the Ansible Docker image, you're getting an official image that includes not just Ansible, but all its dependencies properly configured. The latest tag ensures you get the most recent stable version, though in production environments you might want to specify a particular version for consistency. Running the container with the it flags gives you an interactive terminal session, while -minisarum ensures the container is cleaned up when you exit. This is particularly useful for testing playbooks or running one-off Ansible commands without cluttering your system. Consider creating a Docker volume to persist your Ansible playbooks and inventory files between container runs. This allows you to maintain your configuration files separately from the container itself. The inventory file is one of the most crucial components in your Ansible setup. It defines the hosts and groups that Ansible will manage, essentially creating a map of your infrastructure. The example shown in the slide demonstrates a basic inventory structure with a group called web servers, containing 3 servers. However, inventories can be much more sophisticated. You can create nested groups, define variables at the host or group level, and even use dynamic inventories that pull host information from cloud providers or other external sources. When specifying hosts in your inventory, you have several options for defining how Ansible connects to them. The Ansible_host variable shown in the example is just one of many available variables. Others include Ansible_port for specifying non-standard SSH ports, Ansible_user for the SSH username, and Ansible_connection for defining the connection type. Here's a practical consideration I've learned from experience. While it's tempting to put all your servers in a single inventory file, consider splitting them based on environment or function. This makes it easier to manage different environments and reduces the risk of running playbooks against the wrong servers. For larger deployments, consider using dynamic inventories. These can automatically pull host information from your cloud provider or infrastructure management system, ensuring your inventory is always up to date with your actual infrastructure. Variables in Ansible provide the flexibility needed to make your playbooks reusable across different environments and scenarios. Let's dive into how to effectively manage variables, especially sensitive ones. The slide shows an example of using environment variables in combination with Ansible Vault. This is a common pattern for handling sensitive information like usernames and passwords. The lookup env function is particularly powerful as it allows you to keep sensitive data out of your version control system and inject it at runtime. Ansible Vault is crucial for securing sensitive information. When you encrypt a variables file using Ansible Vault Encrypt, the contents are protected with strong encryption, allowing you to safely store the file in version control. However, remember that you'll need to provide the Vault password when running playbooks that use these encrypted files. Here are some best practices for variable management. 1. Use different variable files for different environments. 2. Keep sensitive and non-sensitive variables separate. 3. Use group_vars and host_vars directories for better organization. 4. Document your variables well, especially their sources and purposes. One common pitfall to avoid is hard-coding sensitive information in your playbooks or variable files. Always use environment variables or Vault encrypted files for sensitive data. Declarative playbooks are at the heart of Ansible's configuration management capabilities. They define the desired state of your systems in a clear, readable format. The example playbook shown in the slide demonstrates installing and starting Nginx. While this looks simple, it embodies several important concepts. First, notice how we're declaring what we want, Nginx installed and running, rather than how to do it. This declarative approach means Ansible will figure out the necessary steps to achieve this state. The structure of a playbook includes several key elements. The name at the top describes what the playbook does. The hosts field specifies which servers to target. vars_files indicates where to load variables from. Tasks list the actual operations to perform. Each task in the playbook is idempotent, meaning you can run the playbook multiple times safely. If Nginx is already installed and running, Ansible won't try to reinstall it or restart the service unnecessarily. It's beneficial to break complex playbooks into smaller, focused roles. This makes them more maintainable and reusable. Think of roles as reusable components that you can share across different projects and teams. Let's explore how to effectively run Ansible playbooks, particularly in the context of CI/CD pipelines, where automation and security are crucial. The command shown in the slide demonstrates several important concepts. The -i flag specifies your inventory file, ensuring Ansible knows which hosts to target. The -vault password file option allows you to securely provide the password for encrypted files, which is essential in automated environments. The -e flags are passing environment variables that will be available to your playbook. This is a common pattern in CI/CD pipelines, where sensitive information is stored as pipeline variables and injected at runtime. Here are some important considerations. 1. Always use -check first in critical environments to see what changes would be made. 2. Consider using -diff along with -check to see detailed changes. 3. Use -limit to restrict playbook runs to specific hosts when needed. 4. Implement proper error handling in your CI/CD pipeline for Ansible failures. One particularly useful pattern I've implemented is creating wrapper scripts that handle common Ansible runs with appropriate options and error handling. This helps standardize how teams run playbooks and reduces the chance of mistakes. Provisioning infrastructure with Ansible extends its capabilities beyond configuration management into the realm of infrastructure as code, IAC. This is where Ansible truly shows its versatility. The slide outlines various cloud providers and services that Ansible can provision: AWS, GCP, Azure, and VMware. Each of these integrations uses specific modules designed for that provider. For instance, EC2 for Amazon, EC2 instances, GCP_storage_bucket for Google Cloud Storage, and Azure_RM_virtual machine for Azure VMs. The benefits of using Ansible for cloud provisioning are significant. The infrastructure as code approach means your infrastructure is version controlled, repeatable, and testable. This dramatically reduces the risk of configuration drift and makes it easier to maintain consistency across environments. One important lesson I've learned: always use separate credentials and roles for provisioning versus configuration tasks. This follows the principle of least privilege and makes it easier to manage access control. This slide introduces VMware provisioning with Ansible, starting with the inventory file structure. The inventory file shown is crucial for managing VMware infrastructure effectively. The inventory structure follows Ansible's standard format, but when working with VMware, there are some special considerations. The web servers group defined here will be used in subsequent playbooks for both provisioning and configuration. While the example shows static IP addresses, in real-world VMware environments, you might also need to handle DHCP assignments and DNS registration. I've found it helpful to maintain separate inventory files for different environments: development, staging, production, to prevent accidental deployments to the wrong environment. Consider using Ansible's dynamic inventory plugins for VMware when managing large environments. This ensures your inventory always reflects the current state of your VMware infrastructure. This slide demonstrates a comprehensive playbook for provisioning VMware virtual machines and configuring them with Nianx. Let's break down this powerful example. The playbook combines two major operations: VM provisioning and application configuration. The first task uses the VMware_guest module to create and configure VMs. Notice how it uses environment variables for sensitive information, like vCenter credentials. This is a security best practice. The hardware configuration section shows how to specify VM resources like memory and CPU. In production environments, you'll want to carefully consider these settings based on your application requirements and resource constraints. The networking configuration demonstrates how to connect VMs to the appropriate network. From experience, I recommend documenting network requirements thoroughly, as network misconfigurations can be particularly troublesome to debug. The second part of the playbook, which installs Nianx, runs after the VMs are provisioned. The become yes directive is crucial here, as installing packages typically requires elevated privileges. A few practical tips around VMware provisioning are: 1. Always implement proper error handling. 2. Consider using VM templates for faster provisioning. 3. Implement proper naming conventions for VMs. 4. Monitor resource usage during provisioning. The vars.yml file shown in this slide is crucial for managing VMware-specific variables securely. Let's examine why this structure is important and how to use it effectively. All sensitive information is handled through environment variables, which is a security best practice. The lookup env function is used consistently to fetch these values at runtime, preventing sensitive data from being stored in the playbook itself. The variables defined here cover all the essential VMware configuration parameters. vCenter connection details, cluster specifications, VM template information, resource allocation parameters, network configuration. I recommend maintaining separate variable files for different environments. This helps prevent configuration mistakes and makes it easier to manage environment-specific settings. A practical tip: document the expected format and requirements for each environment variable. This makes it easier for teams to set up their environments correctly and troubleshoot issues when they arise. This final slide on VMware provisioning covers the crucial steps of securing your variables and executing the playbook. Let's examine these important operations in detail. The Ansible Vault Encrypt command shown is essential for protecting sensitive information. When you encrypt your vars.yml file, it ensures that even if the file is exposed, the sensitive information remains secure. This extra layer of security may prevent serious incidents when repository access was compromised. The playbook execution command demonstrates several important parameters. The inventory file specification, -i. The vault password file reference. The variables file inclusion. Here are some best practices when running VMware provisioning playbooks. 1. Always run with -check first in production environments. 2. Implement proper logging and monitoring. 3. Have a rollback strategy ready. Test the entire provisioning process in a development environment first. Remember to store the Vault password file securely and never commit it to version control. I recommend using a secure secrets management system in production environments. Let's discuss your hands-on assignments that will help reinforce the concepts we've covered in this module on configuration management. Your first assignment is to install a web server of your choice onto a single node using Ansible. This task will help you understand the basics of Ansible playbooks and configuration management. You might choose Apache, Nginx, or any other web server you're comfortable with. This exercise will teach you how to write basic Ansible playbooks, how to manage packages and services, how to verify your configuration, how to handle different operating systems if you choose. The second assignment extends this knowledge to multiple nodes. You'll provision 3 nodes and install your chosen web server on all of them using Ansible. This mirrors real-world scenarios where you need to manage multiple servers consistently. You'll learn how to manage multiple hosts in your inventory, how to handle parallel execution, how to verify configuration across multiple servers, how to deal with potential failures and error handling. These assignments are designed to give you practical, hands-on experience with configuration management. Here are some suggestions for extending these assignments for additional learning. 1. Add custom configuration files for your web server. 2. Implement health checks. 3. Set up load balancing between the 3 servers. 4. Add monitoring and logging configurations. 5. Implement rollback procedures. Remember, the goal isn't just to complete the tasks, but to understand how configuration management makes server administration more efficient and reliable. These skills are directly applicable to real-world DevOps roles, where you might need to manage hundreds or thousands of servers. Feel free to experiment and extend these assignments based on your interests. The experience you gain here will be valuable in your DevOps journey. We've reached the end of our configuration management module, and now it's time for questions and discussion. This is your opportunity to clarify any concepts we've covered, from basic configuration management principles to specific implementation details with tools like Ansible. Don't hesitate to ask about any concepts that need further clarification. Real-world implementation challenges. Best practices and common pitfalls. Integration with other DevOps tools and practices. Specific scenarios you're dealing with in your work. Your questions and discussion points will help everyone learn and understand these concepts better. Remember, in DevOps, sharing experiences and learning from each other is incredibly valuable. I encourage you to also share your own experiences with configuration management, both successes and challenges. These real-world perspectives add tremendous value to our learning experience. Thank you for participating in this module on configuration management. Throughout this session, we've covered essential concepts from basic principles to practical implementation details. We explored various configuration management tools with a particular focus on Ansible. You've learned about core configuration management concepts, installation and setup procedures, working with inventories and variables, creating and running playbooks, provisioning infrastructure, handling security and sensitive data. The assignments will give you practical experience that you can apply directly in your DevOps role. Remember that configuration management is a foundational skill in modern DevOps practices, and the concepts you've learned here will serve you well in your career.